In this video, we learn how to create multiple web scrapers behind TOR using Python and RabbitMQ. First, you need to make sure that you have Python 3 installed in your machine. It is recommended to use virtualenv or any other virtualization like Vagrant, Docker to isolate your development environment across platform if you share your code, and most of the time your production machine will be different from your development, so you want to isolate all the dependencies, etc, etc. So first thing is, after you install Python 3, you need to know the path for Python 3, and using virtualenv we can specify this path, and then env will be the path to install all the dependency of Python 3. Then we will create a requirement file, and this pipe will use this file to install all of our dependencies. So our dependencies are PySox for the socket, BeautifulSoup for the scrapper, to Parse HTML, and Pika for this is the client for RabbitMQ. So after we finished installed creating the virtual environment, we install all the requirements. Oh, we need first to source it. So source env being activate. Now we have Python 3 install, as you can see, and we will install all the requirements. Use this command. Oh, I didn't save the file. Let's check again. Now it will install and return. Now let's move to our file. I call it run. We will start with a web scraper without TOR. This is the URL for the TOR project if you want to check it out, and we'll just make a GET request using a urllib, URL open. I think it's from a request. Need to check it. Yes, so to check the result, just open the URL. And you'll run it as main. So here we'll just print it out. And now we just need to run Python run py. Import. And we can see that we have here the response, and we need actually to read the response. So let's read it, and we can see all the HTML. Now it's not very useful because we want to parse it, and like every web scraper. So we'll just take the title. Let's see, the title here said, sorry, you are not using TOR. So it means that it works, you just need to run behind TOR. So let's solve this. This will be the second thing, to use BeautifulSoup that we already installed, and it's BS4, that's the name of the module. And in order to create an instance, just need to create a new class with the HTML, and let's print it out. Let's print soup that title will give us the title, and get text will clean it out. So let's clean the terminal, run again, and see here the title, sorry, you are not using TOR. Excellent. So this works. Now I want to isolate it into a function. We call it read URL, it accepts URL, and then it just print it. So when we want to run it, we just run here read URL with the URL. Okay, so it should run, it should work. Yes, it works. And in order to run it behind TOR, we need to install TOR to have TOR running. I already started TOR here. you should see the output, you should see an error. If you see something else, you need to go to the TOR project and install the client. If you're using Mac, you can install it with Brew, install TOR, or maybe you have Appgate or APK or whatever. So just make sure you have TOR running. And the port is 9050. Make sure that it's the same port that you are going to write here. And like I said, we need to import socket. Sucks, that's this package from PySucks that we already installed. And we need to configure it before we configure before you're importing the urllib. This is important, okay? Let's write it after we configured Sucks, the socket. So we need to set default to see here 9050. This is the port. And we need to override create connection, which is the function that I will define here. So create connection accepts address, timeout, and source address. And then we need to create the socket to Sucks and connect to the address. So whatever you run in it now, it will try to connect to the TOR. Okay, so if I'm stopping it here now, and I'm trying to run the same script that we ran before, just to read the URL, this is the same thing that we did before, it will give an error. See? Connection refused. So we need to run TOR. If you don't want this part, you need to delete this part if you don't want to use TOR. And you can extract it and have it more. See, this is work. You can extract it and have more control or whatever you want to use TOR or not. Now our crawler runs behind TOR. It takes like time to run through the TOR networks, so keep that in mind. And another problem is that this URL is static. If we want to change the URL, we need either to change it in the code, or we can pass it here and read it later here as an argument. Still, we want to improve this code. And if you have thousands of URL to visit, you have e-commerce, you do it for SEO, you have jobs, tasks that takes a long time, like parsing URL, calculating sort of things using other APIs. You don't want this code to be inside your main thread. You don't want to put it inside the request in your web app, because the user will need to wait for all the URLs, or even for one website. It can be slow. Always when you have external requests, put it outside in a backend job. So in order to do so, we will use RabbitMQ, and we will create some kind of message queue. Say we have messages, a list of messages, and it will pop each message, one message at a time. The crawler will pop a message, and the message will be a URL, and then it will call the URL and do the job. So let's see this in the RabbitMQ website. If you didn't went to RabbitMQ yet, go and download the RabbitMQ, install it in your machine. So this is the simple example of producer, message queue, and consumer. The consumer is the crawler that listens to all these messages and pop one at a time. And each message will be a text representation of URL. And that's it for this example. But actually we are going to use something more advanced. Will give us option to listen to multiple queues at a time, and maybe to have multiple exchange. So exchange is the one that dispatch messages to multiple consumer through messages queue. So like I said, we want to start multiple crawlers. So each crawler will listen to its own queue, and once it's declared a queue, it will bind it to the exchange. we'll have exchange for crawlers. So let's say we have a URL that I want to visit. I'm sending it to exchange, and then it will find to which one to send, which shouldn't matter, to which queue it will send the message. This way we can crawl multiple web pages very quickly and efficiently. Let's go back to the code and see this in action. So the first thing that we want to do is to import Pika. Pika is the client that a RabbitMQ client for Python. And then we want to create a connection. So we're creating a blocking connection. I'm using localhost. And now if I run it, we should get an error because RabbitMQ isn't running. Also, remember to put this in before socket, before the declaration of socks. Why? Because you won't be able to connect later from here after we declare it isn't TOR. So I'm using Docker to run RabbitMQ. I'm not sure if I need to expose these ports or it's exposed by default, but the result will be the same. And I'm using RabbitMQ on Alpine. It doesn't matter, it should work anyway. So now let's see if we can connect. I shouldn't see any error right now. Well, once the script runs, I think it didn't start it yet. No, it started. And yes, it works. It just waited, I guess, for the web page. So now, once I have the connection, I need to create a channel to listen to messages or to send messages, and to declare a queue. Each time we have either consumer or producer, we need to declare a queue. So actually, I will create two functions here. One is blocking, call this consume messages. This is what our web crawlers will use. And this is non-blocking, is publish message or produce message. So consume messages is what the crawler will block on when they are waiting for messages. So if you want to test it on the same script, I will produce message before I consume it. And in each one of them, I need to declare the channel. And the channel will be for the queue test queue. You can change the name, but the names should be the same on each one of them, on the consumer and the producer. Then we'll declare the exchange for the queue. I call it web crawler, which will be for the crawlers. And then we'll publish a message first. So I'm using the same name for the exchange, web crawler. Routing key will be crawler1. The body will be this URL, whatever you want. And that's it. So let's produce message. Let's see if it works. I'm just checking that there is no error. Oh, channel is not defined. Yes, channel is not defined. Okay, so now I send a message, I want to read it. So I need to do the same, to bind the queue here. The same in the consumer, I mean. So I'm binding the queue of this consumer to web crawler. And the routing key is the same. And consume message. Waiting for here it consume message. I'm passing here a callback, a queue name, and no acknowledge. During manually, I should do it, but I'll call this pass actually through. Once it concerns the message, it's acknowledged. We can do it after the callback. Here, this is the callback. We can do it manually and say acknowledge after the task is successfully complete. But for this demo, I'll put true, and let's create a callback. So this is the callback. A new message. And new message will accept the channel, method properties, and body. Actually, let's print the body. A new message. Okay, the last thing that we need to do here is to block. I'm calling channel start consuming. So let's see this in action. I sent a message, and here I can read it in the callback, and you see that this is blocking. The next thing that we want to do is to create multiple consumers at once, and then each one of them will read the message. In order to run multiple crawlers that will consume messages, we need to write another function here. We call it start crawler, and we'll pass args and print them out just to see that we can start multiple crawlers at once. So we are using pool class from multiprocessing, and here we will declare how many processes we want to start. So let's start with 40, and we will run map on this, and we pass the name of the function and it will run 10 times. So let's run this. You can see that it ran 10 times. So now, in order to start to consume messages, each one should have its own connection, and also I will produce a message and create its own connection to the producer. So before I'm doing it, I need to set the proxy in a function. And I'll show you why, because we can't start the connection here before we set in the proxy, because it will run later. So let's call this set proxy, and now we'll run it after restarting our processes. So if you want to test this out, let's run it before set proxy. The read URL, you shall see that we are running without TOR, and if you are running this after set proxy, you can see that we are running with TOR. See, it takes some time because the TOR network is slow. In the meanwhile, I will produce here a message. Yes, it works. And I will set the proxy after I produce the message. I will leave it here. It shouldn't bother us. Now, when starting a crawler, we can actually consume the messages. Yes, we need to pass the connection here to produce message and to consume message. Alright, otherwise, if you remember, it causes problem to connect after we set the proxy. So let's run this, the produce message. It has its own connection. Oh, we need to close the connection actually, because it will open the connection multiple times, and here it will just block on it. So in order to consume message, we need to consume messages, we need to add another parameters to change the routing key, because if you remember, each consumer has its own routing key. So we'll format it. It will be equal to 0, 1, etc., etc. So consume message 0. Let's run this now. And it works. Just doesn't read from the right queue. So consume messages should be here actually. And the argument is the index. Let's run it now. No error. And produce message should also actually, we can pass the routing key to, or the index, and we'll format the routing key here. So now the routing key of the producer and consumer should match. Let's run produce message 1 and 0 and 1. Actually, to test this out, we need to change the URL. See, localhost 0 and 1. So it works. So now the only thing that we need to do is to change the URL. So the body actually should be a different URL. So let's pass here the message in the producer instead just the index. So this should be a message and a key and message. So the routing key should be key. Here a message. Okay, it looks okay. Let's go back to produce message. So key should be, let's do for I in range of 2, key equal polar, and we'll format the message here. And produce key and body of the message will be let's go to the TOR project and let's add just a variable to see that we are actually sending the right message to the right consumer. So we should see different URLs now. See, so it works. So this is how you start multiple crawlers and run them with the RabbitMQ behind TOR and pass the URL here. And if you want to take it a step further, we can actually save it to a data store.